Hello students, welcome back to our next session. So far we have finished our 3 sessions on this particular chapter of applications of integrals, where we are actually dealing with our how to find the area, so bounded by the curves and all. So let's just have a quick overview of what and all concepts that we have discussed so far and what we are going to do in our particular today's session of applications of integrals. So from the beginning, if we talk about our applications of integrals, we have seen the basic definition of it, and then we have seen how we'll be finding the area bounded by any curve with respect to the x-axis as well as any given curve with respect to the y-axis. So those things we have already seen in our first or second session, and after that we have seen what is a symmetrical area, as well as we have covered the positive and negative areas, right? So if we have a portion of areas above x-axis and below x-axis, so how we are going to find these positive and negative areas, so that we have seen. And then coming into the major part which we have discussed, that is finding the area between any given two curves, right? So in these two curves, again we have dealt with some cases, like some types, like one curve with respect to different curves, and then that with respect to x-axis, y-axis. So those and all we have already finished, and for each corresponding thing we have done the questions also, right? So coming to our today's session, we are going to focus on our standard areas, we can say, standard curves, we can say, right? So we are all going to see the standard things in our today's session. So first we are going to start with the sketches of any standard curves. So basically it means, so we know y square equal to 4ax, so it's nothing but a basic parabola. So what is the curve, like what will the shape of this parabola? So it will be like this, right? So not only for the parabola, we'll be having some curves where we can actually take them as a standard. So by looking at the curve, we can exactly draw the shape of it, and we can exactly sketch the figure or graph or plot of that particular curve, right? So that's what we are going to deal today. So first we are going to start with what and all the different sketches which are standard, so that if corresponding curve will come into picture in our question or something, okay, then we can directly, okay, this is our standard curve, so that without any taking some x-axis and substituting in that and taking the y-axis and getting the y value, so without doing all those stuffs, we can directly plot the shape of the curve. And once we got the shape of the curve, then it's easy for us to find the intersection, because by solving both of the curves or both of the conditions which they have given, we can easily try and figure out the intersection points, right? So first our main thing will be drawing the sketch. So initially we have followed our method. So we have followed our old and the method, which is by taking some x value, we're going to substitute in our curve, and we end up having the corresponding y value, which means we'll be having our point which lies on the curve xy, x comma y. So likewise we'll be taking 2 or 3 x values, so we'll be having 2 or 3 points, and then we are straight away we'll be plotting the curves, like we'll be plotting the graph of it. So without even doing all this, for standard curves, we can, by looking at the equation itself, we can go ahead and get the graph of it. So the next thing is standard areas. So same thing here, right? So for standard areas, so for some certain curves, if we take them as a standard, we'll be having a standard. So we can, if we get any question in that curves, so without doing all our procedure of plotting the graph and then taking the intersection points and then doing the definite integration, so we can all skip these steps, and directly we can use that one and only formula which corresponds that, and we'll be getting the direct exact answer. That will be the standard area here, right? And after that is a determination of parameters. So far what we are trying to do? So we are trying to find the area bounded here. So what do you mean by determination of parameters? Any idea? So basically parameter is nothing but it can be any variable, any unknown value which is mentioned in the question, right? So our aim is to find that particular unknown value. If for suppose I have having some, okay, let me do it this way. So okay, so if this is my required area portion, right, and without giving this line I have given some y equal to some constant something, so mx plus c for example. So c is my constant here, right? So I have given the area here. So I'll mention that you have to find the constant c value, which means here c is my unknown parameter. Using the given information, you have to determine the value of this c, which is my unknown parameter here. So likewise, so in this determination of parameters, we'll be having some unknown values, so which we are going to find by using the given conditions here, right? So that's all. So these will be our 3 concepts that we are going to cover in our today's session, and with this our chapter of applications of integrals will be done, right? So with this application of integrals, we just finished, like we'll be finishing our sum part of integrals part, and then we'll be getting into the next part, right? So so these are all related to our integrals, where we have started with indefinite and then we have done definite and then we have finished with applications. So our integrals part will be over by this, right? So let's see. So we are, as I mentioned, we are going to start with the sketch of standard curves first, right? So let's see the equation first, like what will be the curve first, and then we'll be seeing the corresponding figure of it, right? So here the first equation of line we can say. So here we are having a equation of line, that is x by a plus y by b is equal to 1. So this can even be written in another way, that is bx plus ay is equal to ab. Same thing, right? So this line equation is nothing but the same here. So for this type of line equation, your graph will, like your curve will be looking something like this. So this is our x-axis and y-axis, and you will be having like the curve will be a straight line like this, cutting both the x and y-axis. And once we have the figure of it, as I mentioned, we can find the intersection points, right? So this is our first standard curve, and the second is circle. So you already know what is the shape of the circle. It is nothing but what is the equation of a circle first? It is x square plus y square is equal to a square. So in another way, so here the center is origin. So if not, what will be our general equation of circle? X minus h whole square plus y minus k whole square is equal to r square, where h comma k is my center and r will be my radius of that circle, right? So you know the shape of it. So once you can figure it out, the given curve is a circle, then you can directly draw a circle where you can predict the center first, and with respect to the center and radius, you can plot the figure of the circle easily, right? So what about the next figure? So next standard curve which we are having. So the next one will be with respect to the parabola. So what is, so let me just erase this part. So here we are having parabolic equation. So y square is equal to 4ax1, and the other will be y square is equal to minus 4ax. So when we are discussing our chapter of conic sections in our 11th standard, there we have seen our different types of parabolic equations and the corresponding figures of it, right? So I think you guys are aware of it. So here the first curve we are having is y square is equal to 4ax. So what will be the curve of it? So this will be our curve y square is equal to 4x. That means here we can say that our a value is greater than 0. So if in case it's a minus, then the curve will be like this. Right. So similarly, we can have the another parabola, that is x square equal to 4ay and x square is equal to minus 4ay. Right. So the same thing, but y square equal to 4x curve will be like this, and y square equal to, sorry, x square equal to 4a, y will be this way. So this will be our x square equal to 4. So we can write it as b instead of a. So let me take it b. So x square equal to 4by. So this will be my parabolic figure of y square, sorry, x square equal to 4by. If it's a minus 4, that means minus b, then it will be downwards. Right. So by looking at the figure, you can directly do it. Right. So and then what and all conic sections we have discussed. So this is parabola, and then we have seen hyperbola as well as ellipse. So let's see what is the equation of ellipse. So equation of ellipse is nothing but x square by a square plus y square by b square is equal to 1. So this is nothing but a standard equation of a ellipse, and you already know that. Right. So what is the figure of it? So if this is x and y, so this will be your sketch of an ellipse. Similarly, if you have, what will be the equation of parabola, sorry, hyperbola, it will be x square by a square minus y square by b square equal to 1, and the corresponding figure will be this for an hyperbola. So you have to be sure that what is the corresponding equation, like which conic section it belongs to, and the figure. Right. So the previous ones are quite easy for you. So now let's see another type of standard sketches here. So these are not related to our conic sections. These are our logarithmic and as well as our trigonometric functions here. Right. So if you are having a curve, that is xy is equal to c square, and the figure will be looking something like this. Right. So where c is a constant, according to the constant you can get the values, right? And then for trigonometric, you know the graph of sine function, you know the graph of cos function, you know the graph of tan, cosecant, secant, everything you guys already know. So here you can see sine function as well as cos function. So here you can see tan and cot, and secant and cosecant also you can easily get. So you have already seen those typical graphs. And for log x, so y equal to log x to the base e, so the graph will be looking like this. And if you have y equal to e power x, that is exponential, then the graph will be turning upwards like this. So if it's a logarithmic, it will be like this when it turns to be an exponential, because for exponential we can't get the negative there, so it will be turning out like this. So this is our exponential graph, the upper one, and this is our lower one, that is the logarithmic graph. So these are all our quick few sketches of our standard curves, so which you guys can be remember, because while seeing the curves you can directly plot it without following the procedure of substitution values and all. So let's do a question here, easy question, simple, so quickly, and you can let me know the answer fast. A very easy one. So by looking at the figures, by looking at the curves which are mentioned here, you can figure out the sketches of it easily, and you can find the area. So I'll just check for the answers. So if anyone can finish, you can let me know. So let's see if anyone finished finding the answer. You can please let me know the answer We can just verify it, because we have already done many questions related to these type of parabolic curves and all. But why I have just given the question here, so that we can sketch the graph within minutes, like within seconds, because just now we have seen our standard sketches. Quickly guys, let me know. So any answers? Not yet. So quickly guys, very easy. Okay, someone already given the answer 1 by 3. Okay, Siddharth given the answer 1 by 3. Perfectly correct. So what are the curves here? The first parabolic curve is y equal to x square, and the other one is y square equal to x. So first let's figure out the sketch first. So y equal to x square. So the graph will be like this. Just now we have seen y square equal to x, and then x square equal to y will be upward like this. So this is the area bounded between these two. So when we have two curves, so we have discussed area cover bounded by two curves. We have seen when we have area bounded by two curves, how we will be finding upper curve minus lower curve. So this is our upper curve, that is root x, minus lower curve will be this, that is x square dx, and we have to be sure that what are our limits. So one thing is sure, that it is one point will be 0, it starts from, and we have to find this intersection point to get the other limit here, right? So how can we get it? So in place of x, we can substitute y square, I think. So y will be, so we find x, right? So in place of y square, we can substitute x square. So y is actually root x here. So in place of y, we can substitute x square is equal to x power 1 by 2. So if I square, so x cube will be equal to 1. So either way, it will be 1, right? So the limits are from 0 to 1, and here upper curve minus lower curve, that is root x minus x square. So your integration will be 0 to 1 x power 1 by 2 dx minus 0 to 1 x square dx. So if you're done doing this integration part, we end up getting our final answer here, right? So only Siddharth even answer guys so far. So what about others? So anyone others, any doubts or something? So x power 1 by 2. So it will be x power 3 by 2 integration. So x power 3 by 2. Here it will become 2 by 3. So 1 to 0 minus x cube by 3. 1 to 0. So let's substitute 1 because 0, no need of it. So it will be, if I substitute 1, it will be 2 by 3. And here it will be 1 by 3. So 2 by 3 minus 1 by 3 will be 1 by 3 square units. So that will be the final answer here, which is the area bounded by this given two parabolas y equal to x square and y square equal to x is equal to 1 by 3 square units. So I hope you guys got it. So let's move ahead guys. So I think you guys got this one. So let's try and solve this question. So give it a try. Come on quickly. So you have to find the area of the region which is bounded by this line y equal to 3x plus 2 and the x-axis and the ordinates x equal to minus 1 and x equal to 1. So let's draw the figure first. That is your line y equal to 3x plus 2. So once you could able to plot the graph, that will be enough. So the remaining thing will be the integration part and all that you guys can do. So no need of complete solvation here for this question. I just required your plotting of the graph and let me know the intersection points. So that will be enough because you know how to do the integration. So I don't want you to do that. Quickly guys. See here what is the given line y equal to 3x plus 2. Just figure out the diagram and plot it. Take your time guys quickly. If anyone plots it, okay, someone already given the answer also. So exactly correct Siddharth, 13 by 3 square root square unit. So what about others guys? Quickly do it. So I'm not getting any other answers from. So if you guys require some time, you can let me know so that I'll just wait for a few more minutes. I'll give you time. So let's see any other answers. So first plot the graph of it. So you can write it as 3x minus y plus 2 equal to 0. Or else anyways we will have to know the x and y values only. So you can leave it as it is. So that will be the better one. So y equal to 3x plus 2. So take some x value and do it because it is not in our standard form. So the easiest way to go by substituting only. Yeah, we know the exact plot of it. So for suppose if we substitute x equal to 1, what will be the y value? 5. If we substitute x equal to 0, what will be the y value? It is 2. And if we substitute x equal to minus 1, it will be minus 3 plus 2, that is minus 1. So let's plot it. X1 somewhere and y will be somewhere here. Okay, let me take a distance. Okay, let me take x1 here. So 5 somewhere here and x0. So y will be 2 somewhere here. And then x minus 1. So y also minus 1. So somewhere here. So my plot will be like this. It's obviously a straight line. So at x equal to 1 they have given, so we can drop a line here, and x equal to -1, you can drop a line here, right? This one and this one. So what will be the area bounded here by x-axis and these two lines? So which is, this part will be the one thing and this part will be the other thing, and this entire part. So you can take it like this. So this point is when x equal to 1 and y is 0. So this is when x equal to 1 and y is 5. So this is when x equal to -1, y is also -1. So this point is x equal to -1 and y equal to 0. And this is x is 0 but y is 2. Right, so you have to find the area of all this. So if you could able to find this intersection point, so this point of the x-axis and this curve, so we could get the answer. That means here x is 0. Right. So what will be the corresponding for it? So when it actually meets, so this will be meeting when y is 0. So this line will be meeting our x-axis when y is 0. Right. So when y is 0, this will be -2/3. So this point will be -2/3 comma 0. Yes or no? So you know this point, you know this point, and you know this point, and everything you know. So you can apply the triangle part. So you can take this as a triangle and find the half into base into height. One thing. And you know this triangle and you can find half into base into height. If not, you can go by curves also, where you can start from here, that is -1 to -2/3, one thing, because it's a lower part. So modulus you can take. So -1 to -2/3. And what is the curve? That is our line equation. Yes or no? And then from -2/3 to you can go until 1. That will cover this entire area. So there are two types, actually two ways to find this area here. Right? You can follow by definite integrals, and then you can follow by our area, like our triangle also, because it actually forms a triangle. Right? So any of the method will go fine and you will be getting the answer perfectly correct. So it's up to you which one you have to find, because once we plot the graph, we are having a graph will be something like this. And here you can identify what and all the required areas region which we have to find. So this is one of the portion and the remaining will be this entire. And here if you observe, we know this point exact coordinates, this point exact coordinates, this point exact coordinates, which forms a triangle. Again, this point coordinates we already know, this point coordinates we already know, this point coordinates also we already know. So we can easily find the area, which it end up giving the area equal to 13/3 square units. So if not, if you want to go by integration, that's also fine. So let's see by integration. So it starts from here. So what is our x here? That is -1. So x starts from -1 and it will goes until here, because this is our below x-axis. So we have to take it a modulus and separately do it, because when we are dealing with our positive and negative areas, there we have seen whatever below the x-axis, we have to take it separately and do a modulus of it. So -1 to -2/3 one part, and here we have to write in terms of our x-axis only. So it will be 3x plus 2 dx. And this is our area of the smallest triangle here. And this one here, it goes from the x -2/3 to until 1. Right. And what is the curve? Same thing equation. So 3x plus 2 dx. So if we could do the integration also, you'll be getting the same thing by finding the area of the triangle, and also you will be finding the same thing. You can give it a try, and if you have doubts, you can let me know. So here, what is the area of this particular area that is bounded by this line is equal to 13/3 square units. Okay, Siddharth has already given the answer. Okay. So let's move on. So we have seen our standard sketches of curves. So now let's see the standard areas. So you can remember these standard areas as a formula where you can directly apply them and you can get the answer easily. Right. So let's see the first one here. That is area between. So okay, before getting into this part, so can you guys able to do this question or any doubts here? like while doing the integration or the things, you can let me know, and then we can move ahead quickly, guys. So if anyone facing any doubts in this question or while solving this, you can let me know quickly. Because if we could go ahead, if you are okay with it, we can move ahead. Okay, got it. Fine. So yeah, so area bounded by two parabolas here. So we can actually use it as a formula, we can say, for standard areas to finding the area. So here comes the first one, that is when we are trying to find the area bounded between two parabolas. So the equation of one parabola will be y square is equal to 4ax, and the equation of another parabola here will be x square is equal to 4by. Right, so first one y square equal to 4ax and the other x square equal to 4by. So this is our first parabolic graph, that is y square equal to 4x and the other will be this. And the area bounded by these two will be this intersection area. So we just now solved a question related to this where we have taken our curves y square equal to x and x square equal to y. The same thing here. Right. So there we can directly use our formula, that is area here bounded by these two parabolic curves is given by 16 AB by 3. So by comparing whatever the A and B values which are given here. Right. So let's compare here and see. So 16. So what is the A value here? So A will be 1 by 4 and B also 1 by 4 in our previous question, that is x square equal to y. So 1 by 4 by 3. So 16 into 1 by 4, 1 by 4. So 4 cancel, 4 cancel. So it will be 1 by 3 square unit. So if you remember, just now we have solved the first question, which is given to be, which came out to be the area is 1 by 3 square units. Yes or no? Right. So we can use this formula in 1 minute. Within a minute, we can get our answer, the area bounded by any two parabolas. So here, area bounded between these two parabolas, y square equal to 4ax and x square equal to 4by is given by 16ab by 3. So now let's see the next standard area. So that is area bounded by a parabola and a line. Right. So here we are having a parabola and a line. So the parabolas can be of two types. That is, one is y square equal to 4ax and the other will be x square equal to 4ay. Right. So if the first one, if we could able to take, that is x square is equal to y square, right? So if we take y square equal to 4ax and then if we have taken y equal to mx. Right, so the area, so what will be the figure? So y square equal to 4ax, So y square equal to 4ax will be this graph and y equal to mx. So this will be our line. So the area bounded is this portion, which is directly we can use the formula, that is 8a square by 3m cube. Right, if it is 4by, then whatever the b value you can use it. So here instead of changing it to b, I have written in terms of a only, so that the formula remains the same here. Right, so what is the area bounded between the parabola and a line? The formula is given here is 8a square by 3m cube, where a is the value from our parabola and m is the slope of the given line. Right. So let's move on to the next, that is, now the question is parabola, the area enclosed by parabola and its chord. Right, so if you remember, chord is nothing but, so in terms of, we can see lattice rectum. Yes or no, it's something to do with the lattice rectum because we have even done questions related to that. Right, so here you can directly get the answer, that is area between the parabola, which is y square equal to 4ax and its double ordinate. So double ordinate is nothing but it's a chord here. Right, so at x. Right, so at some x point, so this is here. Right, so the x here is equal to a, which means this double ordinate is nothing but our length of the lattice rectum. Right, so that is given by, that is area of AOB. So this entire AOB is given to be 2 by 3 times of area of ABCD. So this entire rectangle area. So once we could get the area of AOB, so that is our entire area, required area, which is bounded between the parabola and its chord. So initially how we have done it, actually this type of question. So we have the parabola here, and we know the double ordinate is nothing but the lattice rectum. So this is our x value. So we know these areas A and B will be symmetrical to each other. So we have found out only our part 1, and then we have multiplied twice as it's a symmetrical area. So that's how we have found it. So without doing those steps and all here, we can simply use the formula, that is the area enclosed by the parabola y square equal to 4ax, and its chord is given by, that is the area of this OAB, that's a semicircle we can say, that is given by 2/3 of area of this rectangle ABCD. So this CB is nothing but A, and this AD is also A. This is 2A. So the length of the rectangle will be, this is 2A, this is 2A, and this is A, and this is A. So this is our rectangle. So where A is the focus of the parabola. Right, so using this, so 2 by 3 times of area of the rectangle ABCD will be equal to the required area, that is enclosed by the parabola and its chord. Right. So the next one here we are having is area enclosed by an ellipse. If we have a ellipse, so what is the standard equation of the ellipse? So general form of equation of ellipse is x square by a square plus y square by b square is equal to 1. So if we have to find the area enclosed by this ellipse, so that area is given by a equal to pi ab. So with these two ab values, we can directly find the area of this ellipse, that is pi ab. So we can directly apply these formulas. So here comes the first one. So you can apply the formula and you can let me know the answer quickly. So find the area bounded by the curve y equal to x power 1 by 2 and the curve x equal to y power 1 by 2. So use the formulas just we have discussed and you can get the answer. Come on guys, quickly. First figure out which standard form of equation is this and which you have to found the area. Quickly guys. Okay, Siddharth already given the answer, 1 by 3 square units. Perfect. So let's see for 2 or 3 more answers quickly. Today no one else are giving the answers except Siddharth. So remaining, quickly do it and let me know the answers. So I'll just give you a few more minutes to work it on. Let's see any other answers. So it's the easiest question, guys. Quickly. Okay, Arun also given the answer 1 by 3, correct. So same type of question we have just solved. Okay, only 2 of you given. So let's see. So here there is no square. So we can square, to eliminate the square root, we can do the square it on both sides, which will be turning out to be y square equal to x and x square equal to y. So this is one parabola and this is the other. So just now we have seen what is the formula for area bounded between two parabolas, that is given by 16 AB by 3. So 16, what is the A value here, which is 1 by 4. And what is the B value here from here? So it will be 1 by 4 again and 3. So 4 times, and here both will get cancelled, which will be 1 by 3 square units. So the area bounded by given two curves, that is y equal to x power 1 by 2 and x equal to y power 1 by 2, is given by 1 by 3 square units. Right. So let's move on to the next one. So here comes the next question, guys. So it is a area bounded by a parabola and a line. Okay, Lakshmi also given the answer. So let's try and solve this question. This is related to area bounded by the parabola and the line. So from parabola, we can get the A value. So basically, what is the formula which we have used here? That is for the parabola and a line. So it will be 8 A square by 3 M cube. So this will be the formula. So the only trick here is the given line graph. The given line equation of line is y equal to not simple x. So it is mod x. So when we have mod x, it will be containing y equal to plus or minus 1, which plus or minus x, which means the graph will be y equal to x and y equal to minus x. So that is the trick and the thing we have to remember in this particular question, where the equation of line is given to be y equal to mod x. So let's quickly do it and let me know the answer. No one given the answer yet, so let's wait for a few more minutes. So here area will be 8a square by 3m cube. So here our y equal to mod x. So when we have mod x, so inside it will be plus or minus x, right? So how will be the graph of this y equal to mod x? Which means we won't be having any negative of x. So any negative of y, we can have x both positive and negative, but the graph will be only y, like only positive in terms of y. So what will be the graph looking like here? So for x, it will be taking both plus and minus. So inside we'll be having both plus x values and minus x values here. But for y, it will be only the modulus, which is a positive. Not it. So by comparing the equation and the parabola, so what is the a value? So a value is directly 1 by 4. And what is m value? M value is directly 1. Right. So but as here the equation of line which is given is mod x. So what will be our figure? So if this is my thing and this is my sketch of parabola, generally y equal to x graph will be like this. So here and I'll be having like this. But here it is mod x, which means I cannot have negative. So this will be coming out to be here. So all the negative values will also be turning out to be here, which means the area bounded by this given parabola and the line will be these two shaded parts which are symmetrical to each other. So then our area here will be becoming 2 times of 8a square by 3m cube. So let's substitute a and m values which we have already found out. So 2 into 8a square, that is 1 by 4 into 1 by 4 divided by 3m cube, that is 1. Right. So 2 here 2 times. So 2 4 times and 4 will be getting cancelled. Right. So here it will be 1 by 3 square units, and exactly Siddharth given the same answer. So what about others, guys? So in this particular question, we can directly apply the formula, but the one and only trick here is the line which they have given is y equal to mod x. So due to that mod x, we'll be having 2 times of the area because we'll be having 2 required areas here. So I hope you guys got this one. So let's move ahead. So here comes one more. So I hope this question you can do it by yourself and let me know the answer quickly. Same model, same typical thing. Okay, got it, Arun. Okay, so let's do the second one quickly. So it'll take hardly 1 minute. So quickly give me the answer. Same model here, but the parabola here is, the equation of parabola is y square equal to x, and the line here is mod by x equal to mod y. So quickly guys, answer. So formula will be the same thing, area equal to 8a square by 3m cube. Why it is 1 by 6? Check it once. Here also it's modulus, Siddharth. So I hope you didn't consider here it is a modulus. So here also what will be the graph? So y square equal to x. So it will be like this. And we'll be having the graph that is x equal to y. So it will be like this part here. So there is no turns. So this part here. So this is the required portion. So as the two parts, again here our area will be equal to exactly. So it will be 1 by 3, correct. So 2 times of 8a square by 3m cube, like how we have done the previous one. So 2 into 8 into a square is 1 by 4 into 1 by 4 and 3 into 1. So denominator 16 and here 16 both will get cancelled and it will be 1 by 3 square units. So I hope you got it. So let's get into the next one. So the next one we are going to see here is determination of parameters. So as I mentioned, so it can be any parameter like some constant A, B, C, something like that. We'll be having a variable which is the parameter and we have to find the, we have to determine the parameter value using our given condition. So let's see the question here. So here you can observe a question. So this is related to our determination of parameter. So find the value of C. So here C is our parameter. So C is the parameter which we have to find the value, right? So find the value of C for which the area of the figure bounded by the curve. So here we are having two curves, that is y equal to 4 by x square and x equal to 1 and y equal to c. So here we are having these three curves and the area bounded by these three curves is given to be 9 by 4 square units. So using this area you have to find this unknown parameter c. So quickly do it guys. So it's the same thing. Initially we used to find the area, but here area is already given. So we will be finding our definite integrals area and we are going to equate it to y by 4 so that we can determine the unknown parameter c here. So first plot this graph y equal to 4 by x square. So you have to plot the graph of this y equal to 4 by x square, then only we could easily get it. So let me take the thing. So you just give it a try first, and after that I'll just show you the figure and everything, like our integrated part and all, so that the next step, the integration part, you already guys know that. So first you just give it a try, and then I'll just let you do it. I'll just explain it to you. So there is nothing new here. So initially we used to, so even this C will be given and we used to find this area, but instead of that, here C is unknown and we have to find the C value, and the area bounded here is already given. So let me see if anyone solved. At least you could able to figure out the integration part and equate it to the integration area part, so that you can equate it to, and the next steps are easy to find the, so to just do the simplification and all. That's it. So here if you see, what will be our x equal to 1. So let me take it here, x equal to 1, and let me take y equal to c somewhere here. So the next thing is y equal to 4 by x square. So this curve will be having the graph something like this. If you could plot, you will be getting. So this is the required portion of area which we have to find it. So to get that, what we have to get here, so this is x, this point is where x equal to 1. So if we could get what is the x point here, that is, this is the intersection of our curve, that is y equal to 4 by x square and c. Right, so in place of y, we can substitute c, that is c by 4x square. So x square is equal to 4 by c. Right, so x will be equal to 2 by root c. Yes or no? So this point is nothing but our intersection point. So this is 2x will 2 by root c. If x is 2 by root c, what will be the y? X square will be 4 by c. So 4 by c, 4 for y will be c. So this point of intersection of the curve and the line y equal to c is given to be 2 by root c comma c. And this is our line y equal to c, and this is y x equal to 1. So this is the area which we have to find. So what will be our integral part here? So integration starts from, so the curve will be coming like this. So I am going to start the x point here. So my interval, so my limits here will be 2 by root c to x equal to 1. And what is the upper curve in this entire figure? The upper curve will be my y equal to c. Yes or no? So my upper curve here will be y equal to c. So in place of, I can't write in place of y. So it will be c minus the lower curve is my this curve, which is 4 by x square dx. So this is my integration part of area, and this is already given that this area will be equal to 9 by 4 square units. So now what is our thing? We have to simplify it and we could get our c value here. Right. So I just shown you the figure here, what is the required area, and I have even given you the corresponding integration, how we'll be writing the thing here. So you can just give it a try this, and you can find the C value because it's a simple definite integration part of it. Right. So I hope you guys can do this simplification later and let me know the answer. Right. So I'll just give you the final answer of C. So C value will be either, there are two values, it can be 1/4 or 49/4. So you can check it after the simplification, and I have few more questions for homework. So this is one question for you guys to work it on, homework question. So this is also, you have to find the area bounded between two lines. So it's one homework question. And the other one here, that is our area which is related to parametric form. We have seen the questions for area of parametric form. So you can take this also homework and simplify it. So here I have given two questions for you guys to work it on as a homework. So with this session of our applications of integrals, we just finished our integrals application part of it. So this will be our last session, guys. So hope you guys clearly get the points of our today's session, and if you have any questions, any doubts while solving the homework questions or anything else, you can let me know in our next session. So hopefully in our next session we'll be starting a new chapter. So it's nothing but a differential equation. So again, in the differential equations, again we'll be having some of our integrations. So that we'll be seeing in our differential equations. So that's all for today, guys. So let's just start a new chapter in our next session. Thank you.